Hello, Geometry Honors. Well, today we're going to look at the we're going to look at the rest of 11.6 areas of regular polygons. And what we learned yesterday was a little bit of vocabulary, but we also learned that there was a formula that you could use on every regular polygon to find its area, and it was 1/2 times the apothem times perimeter. And so we did an example. We also realized sometimes it's beneficial to find this measure of the central angle. That can help us to find missing lengths that we need. Let's move on, if you would, to example 3. It says an equilateral triangle is inscribed in a circle. Inscribed means it's inside of the circle. Circumscribed would be around the shape. So this equilateral triangle is inscribed in a circle with a radius 8 units. Find the perimeter and the area of the triangle. Well, we could draw a picture of this, couldn't we? Let's go ahead and do that. We've got an equilateral triangle. Says that it is inside of a circle, so that means the circle is circumscribed around it. And they're saying that it's got a radius of 8 units. So that would be a distance out to there, wouldn't it? So that is 8 units. Also, there would be 8 units. There would be 8 units, right? And they want us to find the perimeter and the area of the triangle. Well, we know that to get the area of the triangle, we could do 1/2 base times height. That would be a way to go about it. But an equilateral triangle is also a regular polygon. So we could also do area is equal to 1/2 the apothem times perimeter. But we run into some issues here. Having the radius doesn't give me the apothem. And also it doesn't give me a side length of the triangle either. But just like in the example before, if we're not given some measurements that we need, we might be able to solve for them after we know the central angle. So I'm going to go ahead and take a moment and do 360 divided by 3 sides, which means our central angle is going to be 120 degrees. Well, if our central angle is 120 degrees, then what we could do is drop an apothem down here, like so. So I'm going to zoom in on this a little bit, just so it's not so tiny. But if we drop an apothem in here, it's going to split up that 120 into 60. And guess what we've got? We've got a 30, 60, 90. And our hypotenuse is 8. So if we've got a 30, 60, 90 triangle, that means that our apothem here is the short leg. We know the hypotenuse. The relationship between the short leg and the hypotenuse is multiplying by 2, doubling it. So to go back to the short leg, we would divide by 2, which means our apothem is 4. Now we still need to find the perimeter of the equilateral triangle, but that won't be too bad. You can either use Pythagorean Theorem or save yourself some time and realize that this portion of the side is going to be equal to the short leg times square root 3. Now that's only this part right here, isn't it? So if you double that, you'll get 8 square root 3 all the way across. Multiplying this by 2 will get you 8 square root 3 for the whole thing, right? And how many sides do you have? You've got 3 sides, each with a measure of 8 square root 3. So our perimeter is 24 square root 3. Well, we can now simplify that, and we can get an exact answer of, let's see, half of 4 is 2, 2 times 24, 48 square root 3. What were the units here? Oh, they were just units, so I guess we could say units squared if we wanted to, or just leave them off. And then that's an exact answer, but sometimes people want a rounded answer, so let me grab a calculator real quick. And I get 27.71. Oh, wait, no, that's... Yeah, no, that's not right. Let me, I forgot to multiply by something here. So we've got 48 times 3 square root equals, our area is 83.14 units squared. Sweet. Well, that was the area. They were also wanting the perimeter. Well, that's not so bad. Didn't we have to get the perimeter essentially to get our area? So there's our perimeter hiding up there. Our perimeter was 24 square root 3 units as an exact answer, or we can write our perimeter as square root 3 times 24, 41.57 units, rounded to the nearest hundredth. Find the perimeter and area. So yet again, the central angle came to the rescue. It allowed us this time, because we were given the radius, it allowed us to then find the apothem and half of the side length, which we could then multiply by 2, multiply by the fact that we've got 3 sides to get our perimeter, and as a result, also be able to get our area. All right, let's do a few more of these. Example 4 is asking us to knock out a bunch of them. Well, for example 4, it says find the area of each regular polygon shown. So area is equal to, since they're all regular polygons, 1/2 the apothem times perimeter. In this case, we've got an apothem of 5.5 centimeters because it makes that right angle with the side. And with the side length being 8, we're going to multiply that 8 by 1, 2, 3, 4, 5. And we're going to get 40 centimeters, which makes our area 20. I just did half of 40, so 20 times 5.5, which is 110 centimeters squared. All right, next up. Again, we're going to have area is equal to 1/2 the apothem times perimeter. Our apothem is 6 square root 3, and our perimeter is unknown. But if you'll recall, if we've got a right angle here, we've got a right triangle. So we can totally do Pythagorean theorem here to find this missing half of a side and then multiply by 2 and multiply by 6 to get the perimeter. So let's do that. We'll do it up here where we got a little bit of space. So we're going to find, we'll call that x. So we're going to have 12 squared is equal to 6 square root 3 squared plus x squared. Square the 12, you'll get 144. Square 6 square root 3, you get to square both of them, so it'll be 36 times 3, which is 108 plus x squared. And maybe we'll look out here. Let me see if it comes out nice. So I'll do 144 minus 108 equals 36. Square root of 36 is 6. Now keep in mind that 6 is just half of a side. So a whole side is going to be 12 centimeters for a whole side times 6 makes 72 centimeters. And then from there we can clean it up. So 3 times 72, 216 square root 3 centimeters squared for our area. Or we can get a decimal value. We'll do 3 square root times 216. So 374.12 centimeters squared to the nearest 10th. 100th, my bad. All right, well, we're doing good there. Now, I was just thinking, you totally could have done this another way. If you didn't want to do Pythagorean theorem, you could have found the central angle like we've done previously. So let me think there. 360, oh, this is another hexagon. Seems like we do those a lot. So I'll divide it by 6. The central angle is 60, which makes this 30 degrees. And they tell us the hypotenuse and the long leg. Either way, to go back to this measure, you're gonna get 6. You're either gonna divide by 2, divide 12 by 2 to get the short leg, or you're gonna divide the long leg by square root 3. And so you're gonna get 6 either way. And that totally is probably a little bit quicker than doing Pythagorean theorem. The only thing is if you don't end up getting a special right triangle, it really doesn't help you out that much. You could use trig, but Pythagorean theorem is more accurate. All right, let's look at our next picture here. We've got, okay, so looks like we don't have the apothem yet. Oh no, we do, it appears we do at least. I'm gonna assume we do. They don't have the right angle there, but it's a distance out to the center, so I'm pretty sure that's what it's gonna be. I guess I might be able to check it by doing some Pythagorean theorem stuff to just verify, but yeah, to me, I don't know what else that could be. If it's not the apothem, it's gonna be a difficult problem to do. So we got 1/2, the apothem is 15. And the perimeter would be 9 times 1, 2, 3, 4, 5, 6, 7, 8. So 72 inches. And that'll be 36 times 15, 540 inches squared. And lastly, we've got a square. It looks like a square. Yeah, I think it would have to be a square. So we've got this square. Well, yeah, it said it's a regular polygon, so a regular quadrilateral has to be a square. We've got this square, and it appears we've got an apothem again. All right, so yeah, we could do we could do base times height to get the area of a square. We could do, since the square is a rhombus, we could do 1/2 diagonal times diagonal. But since we're in this unit of study, let's use the regular polygon area formula. So we'll go 1/2 apothem times perimeter. But we've got the apothem of 4 meters, but we're going to run into some issues here because we don't have a side length. Well, I don't know if you guys recall this. Let me flip it on its side real quick. But if you draw diagonals in on a square, the diagonal here is actually the diagonal would be the diameter of the circle, so the radius would be half of it. But when you draw those in on a square, it's always going to be, it splits these right angles up perfectly. So this is going to be a 45, 45, 90 triangle. And because we know that, it turns out that the apothem is across from a 45. This half a side length is across from a 45. So half of it's 4. That means our total side length is 8. So it's going to be 8 meters times 4. Our perimeter is going to be 32 meters, which makes our area, half force 264 meters squared. Bam! We got it. So it's kind of fun. You could also do 8 squared, right? Side length squared is 64. You could also do diagonal of, what did we say the diagonal was? Oh, we never found it. But the diagonal would be 4 square root 2. So you do 4 square root 2 times 2, and then multiply that by whatever that answer was, cut it in half, and you should get 64 as well. Okay, so there's a bunch of examples. Now these can get a little tricky. Some advice I'd give you is if your picture you have things are getting cramped, go ahead and draw it, blow it up and draw it outside here. Don't make it difficult on your brain to see all the relationships. Take that difficulty out of it. Redraw the picture real quick, bigger. Redraw that triangle bigger. Then you can work on what you need to find there. And just be aware, realize that if you're getting, this base of this right triangle, that's just half of the side. So just kind of be wary of those things. Also pay attention to the vocabulary. If they're talking about a hexagon or a heptagon or just any of those polygon names, pentagon, hexagon, okay, all that stuff, that what those are referring to. Well, the practice for this is page 765. Numbers 1 through 5 all, and 7 through 29 odds. And listen, everybody, I would like for us to quiz over this tomorrow. I will take some time to answer any questions you have, so please practice these, come in with questions, and then we'll take a short quiz over it. Have a great day. Thank you.